Hello everyone, my name is Dami and I will be giving a lecture on the topic the matrix approach to linear regression model. So firstly, what is a model? A model simply is a representation of a big problem, and when we want to write a model, it will look something like this. Y is equals to beta 1 plus beta 2 x2 plus beta 3 x3 dot 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 plus beta k xk plus u, where this stands for our sorry where this it goes for our dependent variable, and this is our intercept, and this is the partial slopes of the coefficients of every variable, and this is our variable 1, this is our variable 2, this is our variable 3. And what this is simply saying, for instance, when you are looking at something, probably what are the things that that are the determinants. For example, now the determinants of we'll crop it. All right. Mm. Okay, for example, we want to look at the determinants. When I say determinants, I mean like the factors that affect probably participation in non-farm employment. We can say maybe their age. So X2 will stand for age. Maybe X3 can go for household size. X4 can go for their family income, and so on and so forth. So U here, what I mean by U means the stochastic or the disturbance term. And why this term is very, very important in a model is because we want to believe that whatever variables, even if you have up to 50 variables in your model that you've already stated out, there are still some variables that would actually affect our dependent variable now, which is non-farm employment, which probably you did not think about, or because of some issues, you could not really find a way to capture them. So this U will stand for all those variables that you were not able to capture. So I said before that our better one is our intercept. When we say intercept, probably when you have a graph, this is our y-axis and this is our x-axis, and then you plot all your x's, and it's something like this. So this is our beta one. That is where it intercepts at the y-axis. And then when we're talking about our beta 2, for example, when you plot your graph, we do know how to calculate our slope, and you have like a triangle in this format. When you have a triangle in this format, that is y2 minus y1 over x2 over x1, we have our slope. So that is what I mean when I say slope. So moving forward to why we are actually here, we're talking about the matrix approach to linear regression model. And yes, before we go on, I've been talking about linear. I'm sure some of us may be wondering what linear means. When we say something is linear, it will come in two forms. There is linearity in variables, and there is linearity in parameters. So when we say something is linear in variables, we've already established the fact that our x's are variables and the betas are our parameters. So when we say this model is linear in variable, we're talking about the x now, they are all raised to the power of 1. If we have a model like this where this is our y, our dependent variable, the beta 1 plus beta 2 x2. If, for example, the x is now raised to the power 3, this model is no longer linear in terms of variable. The same goes for our parameters. Usually the parameters are supposed to be raised to the power 1, but the moment when you're having a parameter that is raised to power anything greater than 1, it means that it is no longer linear. But for our main focus, talking about the linear regression model, because we want to deal with OLS estimation, that is the ordinary least square estimation. That is our OLS. Our main focus is that every single parameter must be linear. So do we get it? Beta 1 must raise to power 1, beta 2 raised to the power 1, and so on and so forth. So moving on to, sorry about this, moving on to the calculation aspects. For example, when we have a question like this and we are giving our n stands for number of observation, and we are giving our n as 10, n is equals to 10, and our summation x is equals to 1700, and our summation x square is equals to 322,000, and our summation xy is giving us 205,500, and our this should be summation y square giving us 132,100, and summation y giving us 1110. So looking at this, we could already discover that this is a 2 by 2 matrix. It is a 2 by 2 matrix. And how do I know that it is a 2 by 2 matrix? Usually when we want to, because the question, okay, let me take the question first before I explain. And they give us this question. This is question number 1, and we are told to estimate beta 1 and beta 2, and we're also told to obtain the variance of beta 2 with a hat and beta 3 with a hat and their covariances. And the third question is obtain R square, where our R square stands for coefficient of determination, and our R square bar. So the first thing to do when we are given a question like this is to draw out how the matrix is going to look like for a 2 by 2 matrix. So this is what it looks like. N here, which is our number of observation. Then we have our summation x here. Then we have our summation x also here. Then we have our summation x square here. Then we close the matrix. We open another squared bracket where we have our beta 1 and we have our beta 2, which is equals to summation y summation summation x, y. So I was saying something about knowing when you are dealing with a 2 by 2 matrix and knowing when you are dealing with a 3 by 3 matrix. The simplest way to know when you are given the question, usually if it is a 3 by 3 matrix, they would ask you they would ask you to estimate the parameters. And in this question, we see just two parameters. So definitely we know we are dealing with a 2 by 2 matrix, which is just the beta 1 and beta 2. But for example, if it were to be a 3 by 3 matrix, we would have been told to estimate beta 1, beta 2, and beta 3. We will get there. But for now, let's focus on 2 by 2, 2 by 2 matrix. So the first step in calculating Roman figure 1, that is estimating our beta 1 and beta 2, what we do is this. We have our x prime x. And all these, they all have formulas, or rather, they have things that we'll use to know that, okay, this is how we're going to solve it. So to get our x and the comma apostrophe x, what the formula looks like this, where we have our n, number of observation, we have summation x here, then we also have summation x here, then we have summation x square. So this is the first step. So why we are doing this, why we have to do this is because to actually get our parameter, which is our beta, the formula is this. Raised to power minus 1 and x, y. So this is what we use to get x, x. But to get our x prime y, the formula is this. X prime y is equals to summation y and summation x, y. So this is it. Now that we know that this is what we have to do to get our parameters, which is the first question that we were asked to do. So when we know this and we have it at the back of our minds, we then go back to the question and then we look for what n stands for. It will always be given to you. You will never have to calculate it. It will always be given to you. So you look for what n stands for, look for what summation x stands for, look for what summation x squared stands for, and so on and so forth. And going back to the question is already given there. So all we have to do is just to impute it in our brackets. So x prime x is going to be equals to 10. N was 10. Our summation x is 1,700. Our summation x is 1,700. Our summation x square is 322,000 as given in the question. So usually before you want to actually use the matrix approach in solving the linear regression model, you need to have like a fundamental idea on how to solve, on how to calculate using matrix. And that is one of the problems that we normally have. But when you have the fundamental knowledge, basic knowledge, talking about addition in matrix, division in matrix, multiplication in matrix, I think you should not find it difficult. But regardless, I'm still going to take us on this journey. I'm going to teach us what we actually have to do to solve this. So firstly, when we have something like this, the arrow goes like this. I like to do mine like this. So, meaning that what we do is that we multiply 10 times 322,000 and we subtract it by 1,700 times 1,700. So it looks like this. 10 into 322,000 minus, pardon me, okay, let me just erase this, minus 1700 into 170. That's what we are talking about. And when we do the mathematics and everything, this should give us 322,000 and an extra zero, and this should give us 289,000 and an extra zero. So when we subtract and do the mathematics, our answer should be 3300. Please and please, when you are watching this YouTube video, the easiest way to grab whatever I'm saying, that as I am calculating, please grab your pen and paper and your calculator and follow the steps. Don't just watch and think that in the middle of the night you can wake up and you remember everything that we are studying here. This is econometrics, this is mathematics. You have to follow it step by step, and you have to also do your part. So why we did this is because actually we are trying to get the adjunct of this. I said adjunct. I'll write it out. Adjunct of this x prime x, which will actually be equals to 1 over x prime x. So we just calculated this x prime x. So we know that x prime x, using the matrix whole rule and everything, this is our answer. So then we know the adjunct of x prime x is going to be 1 over this figure that we got here. Okay, I'm sure that was taken. So first step done. So moving on to the next, when we have gotten our adjunct of x prime x, we then go forward to get our transpose of the cofactor. Yeah, transpose of cofactor x prime x. How do we go about that? Or rather, how do we handle something like that? This is what we do. Remember what was in the bracket earlier. When we have n here, we had summation x, we had summation x here, and then we had summation x squared. So you take it back also, write the figures that were there: 1,700, 1,700, and 322,000. Yes. So how do we then get the transpose of the cofactor? We do this, we put a plus sign here and we put a minus sign here. So when we are doing this, talking about transpose of the cofactor, when we are doing this, usually it's almost as if the matrix is going to flip, and then it's going to look like this, because we're talking about transpose. So it's now going to look like this: cofactor x prime x be equals to 322,000. So 332,000 that was underneath, it comes upwards. It's like this is how the arrow is going to be like. So what was here before, it moves here, and what was here, it comes here. So something like this when we are doing the transpose. And the same thing goes with this one. It will look as if it's the same, but it's actually not the same. The reason why it's looking like as if it's the same is because we have the same value on the both ends. But for instance, if 56 was here and 1,700 was here, so 56 is going to come down here and 1,700 will come here, and then our 10 will come here. But because we are dealing with the same numbers, that's why it looks as if there was no interchanging in this particular section, but there was actually an interchanging. So, and a key thing, you remember that before we did the transpose, we put some symbols here. We said this is plus, this is minus, this also should be minus, and this should be plus. That's how we do it. So plus, minus, then we are going down, we go minus, plus. So what does that signify? It means that 1700 carries a minus sign here. 1700 carries a minus sign here. I think I want to write this out again to foster our understanding, because there was a whole lot of write-ups in that bracket. Yes. So we said this is plus, this is minus, this is minus, this is plus. So that is why our 1700 here is having a minus sign. This one is also having a minus sign. But because these two remain as plus, so we leave it like that in the bracket. So we've successfully gotten our transpose of the cofactor. If you remember clearly, we had an adjunct here. So when we are solving further, it doesn't stop here. Then what we do is, because if you remember from this formula, this is what it looks like. So we've been able to get this, because it's just like when they say 5 raised power 1. If you want to simplify this, this is what it's going to look like: 1 over 5. That's why we have to go to this journey to actually get this. But to bring everything together, this is what we are going to do. We are going to bring that 1 over 330,000 multiplied by our transpose of cofactor, which is this. Yes, so this is what it should look like, and this is the easiest part of matrix that I like, and I believe every one of us, we should actually love it, because you don't really have to think so much. So basically, what are you doing here? It's just like regular division. It is actually division. So what we are going to do is that 32200 divided by this minus 1700 divided by this also, minus 1700 divided by this also, and 10 divided by this also. So when we do the division, this is what it is going to look like. Probably I should actually just write it out in case we're not really following what I was trying to say. Yeah, this was what I was trying to say when I was saying this divided by this divided by this. Okay, so I have simplified this already, and by now we should understand what I have been saying. And this is actually to get this. Okay, so when we are done with this, I personally, I always like to leave my formulas in fraction. Some of us, we may choose decimals. There is no problem. If you want to divide and leave your final answer in decimal, or you want to divide and leave your final answer in fraction, it depends on what suits you best. But for this study, I'm going to be leaving my answer in fraction. So when we divide this, this is what our answer should be. If you are not getting this answer, you are wrong. Probably you should try um, using your calculator again. Yes. So this is what the answer should look like. And if you remember, before we came to this section, when we are trying to look for our parameters, we just got this aspect, and there is still x prime y. So we are still going to multiply this by our x prime y here. And I already gave us what x prime y looks like in the matrix. What it looks like is there is a summation y at the top, and there is summation xy below. And looking at our question, we know that our summation y is 1110, and our summation xy is 205 500. So we're going to be multiplying our final answer here with that particular thing. So moving on to the next page. So to get our beta, I will write out the formula again for us. Yes. I'm sure we'll understand what I mean by putting this dot sign here. You can use it inversely. Whether you use dot or X, it means multiplication. So that is why it is there. So putting our final answers, so this is what it should look like. You open your matrix brackets and you have 161 over 165. Then we have minus 17 over 3300. We also have minus 17 here over 3300. We have 1 over 33000 here. Then multiplying that. So where our summation y is 1110 and our summation xy is 205 500. Now going to another matrix rule, we are trying to multiply using matrix. So how this will go is, this is what we do. 161 over 165 multiply by this. So when we multiply this, we then add it to this multiplied by this. That is 205 500. So I want us to grab our scientific calculators very, very closely to us as we do the multiplication. So this is what it's going to look like. 161 over 165 into 1110 plus minus 17 over 3300 into 205 500. So when we do the mathematics, this should be our answer. 269 over 11 for this top part. For the second part, this is what it should look like. Minus 17 over 3300 into 1110 plus 1 over 3300 into 205 500. So when we do this on our calculator, our end result should be 28 over 55. So going back to the previous page, so 269 over 11 will be at the top and 28 over 55 will be at the bottom, meaning our final answer is this: 269 over 11, and we have 28 over 55 here. So for some of us that we really love using decimal, this is the time that you should be happy. Yes, we are going to convert the fraction to decimal. So when you convert 269 over 11 to decimal, we should have 24.4545. And when we divide 28 over 55, we should have 0.5491. And permit me to say this, it would be preferable to leave your answer in 4 decimal places. Try as much as possible. If you cannot go 4 decimal places, maybe 3, but I will recommend 4 decimal places. So we know that what is on top now stands for our beta 1. Stands for our beta 1, and this stands for our beta 2. So we have successfully answered the first question. So moving on to the next question before I end my session with you, we found our parameters, which is the intercept and the slope. where our intercept is our beta 1 and our slope is our beta 2. Now we are to obtain the variance of the estimated value of beta 2 and the estimated value of beta 3 and their covariances. And this is the formula to do that. It's going to be variance covariance beta is equals to this. This is sigma x prime x raised to the power of 1, where this sigma, it stands for u prime u over n minus k. When we say n, we mean number of observation, and when we say k, we mean number of parameters. For this question, we were given just two parameters, which is beta 1 or beta 2. Most of the times, people think that when we are giving n minus k, it means the number of observation minus 2. It's not every time that you subtract from 2. If you have three parameters in your model, if you have beta 1, beta 2, and beta 3, it will be n minus 3. But for this question, we have just two parameters. That's why we are leaving it as n minus k. So bringing out this, we have our y prime y minus beta 1 x prime y all over n minus k. So this is what we actually want to do. So to get our y prime y, there is another formula. I'm sure the major reason why some of us we do not really like econometrics is the fact that the formula doesn't ever finish. Yes, you will continue to keep a lot of formulas in your brain and in your heart. So x prime y, it simply means summation y square. And if we go back to our question, we see that our summation y square is 132,100. So going back, that's just basically equals to 132,100. So we don't really have much to do here. We don't really have much to do here. So we are trying to look for this. So we're going to put it inside the formula when we already know our y prime y is 132,100 minus our beta, that is our parameter that we looked for. Look at the answer. The answer was given as 24 points, this and this. But when we are putting it into the formula, we are going to, it's almost like when we are saying we are doing the transpose. So I know it was vertical before, but we're going to turn it in an horizontal manner. So it will then look like this: 24.4545 and 0.5091 here. Then we close the bracket. Then x prime y, we already found our x prime y somewhere here. This is our x prime y. This is what it looked like. So we're going to put it into the equation. 1110, and we have 205,500. Yes. So this is what we're talking about. Now, n minus k, our n usually, not usually, the question gave to us that our n was 10. Our k, we have two parameters, so minus 2. So this is what we are doing. So moving on to solving, I'm trying my best to be fast now. So this will be 132,100 minus this. Sorry, I'll go back. So how we're going to expand this matrix is that this will be multiplied by this. 24.4545 we multiply by this. Then we add it to 0.5091 multiplied by this. So this is what it's going to look like. 24.4545. That's times 1110 added to 0.5091 times 205,500 all over n minus k. That is 10 minus 2. 10 minus 2 is 8. So I just want to put 8 there. So when we expand, or rather open the bracket, it will be 132100 minus 131,761.54, close the bracket, over 8. So when we subtract 132100 from 131,761.45, we should get this. If you imputed that on your calculator, well, the answer should be 338.46 divided by 8, giving us 42.3075. Now we have gotten our sigma, but if you remember, the formula is longer than that. We just did this aspect, so we are now going to multiply it by our x prime x raised to power minus 1. So the good thing about this x prime x raised to power minus 1 is that while trying to solve the first part of this question, we already brought it out, which is this. So all we're going to do is to multiply that with our final answer. So it should look like this: 42.3075 into 161 over 165 minus 17 all over 3300, then minus 17 over 3300, and 1 over 33000. So the same way we divided in the matrix is the same way we're going to multiply. So what we're going to do simply is 42.3075 multiplied by this, then 42.3075 multiplied by this, and go to the bottom, 42.305 multiplied by this, and also do it for this. So our final answer, when we get our final answer, we should have at the back of our mind that what is on top here is the variance of beta 1. What we get here is the covariance of beta 2. What we get here is the covariance of beta 1, and what we get here is the variance of beta 2. So this is another formula that we need to have at the back of our mind if we want to be someone that is successful in matrix. So this is it. Now, going to the last question before I round up my session. Obtain our coefficient of determination. So the formula for this is r square is equals to estimated beta x prime y minus n, number of observation, y square all over y prime y minus n square. And this is also the same thing as ess over tss. Before the end of this session, I should give the full meaning of ess and the tss. Okay. Going further to solve this, our beta 1 x prime y is something we already solved earlier while trying to solve the first part. And if you remember, just check your notes, because I already told us that we should be solving as I'm solving. The answer was 131,764.545. This was our beta 1 x prime y. And our y prime y, we solved that earlier. The answer was 1 tss. Before the end of this session, I should give the full meaning of ess and the tss. Okay. Going further to solve this, our beta 1 x prime y is something we already solved earlier while trying to solve the first part. And if you remember, Just check your notes because I already told us that we should be solving as I'm solving. The answer was 131,764.545. This was our beta 1 x prime y. And our y prime y, we solved that earlier. The answer was 132,100. Our n is giving us 10. Now, y bar, we may have been wondering how are we going to solve this y bar. So what we do to get our y bar is summation y all over n. From the question, we know our summation y is 1110, our n is 10. So this is going to give us 111. And do not forget, in the formula is actually y bar square. So y bar square, it will be 111 square, which is 12321. So that is it actually. So we put all this into the formula that was given earlier, which is this minus 123,210 all over 132,100 minus 123,210. So when you do the mathematics, the answer would be 8554.545 all over 8890. So when we divide this, this is our answer. So we've succeeded in calculating our coefficient of determination, where r square is equals to 0.96226. So if you were able to succeed with me this far, you should be very, very proud of yourselves, because you know that in your examination, you will not have any problem. Even if the lecturer wants to set the question from the pit of hell, just know that you have Jesus with you and you will not have any problem. So the last part, which is r bar, this is the formula: 1 minus n minus 1 all over n minus k into 1 minus r square. So 1 is here, minus n is 10 over 1 into 1 minus, if you remember, answer for our r square was this, so we put it in the formula: 0.9622. So when we solve this, this should give us 1 minus 9 over 8 into 0.0397, and the final answer would be 0.9576. Taking us back to the first question, we have been able to estimate our beta 1 and beta 2. We were able to estimate the variance of our beta 2 and beta 3 and their covariances, and we have been able to estimate our coefficient of determination and coefficient of determination bar. So I want to believe with this, we'll find it very, very easy in learning and assimilating this aspect of econometrics. So it was nice having you, and I'm sure you enjoyed having me also. So see you later on this episode. Bye.